molecule I got was C2H2Br2, but before we really get into the specifics, I'll explain the electron configuration so we can find out the different energy levels for each electron and the locations of the electron. So we'll basically kind of build the structure of each element before we actually build the structure of the entire molecule. So I wrote out some bullet points. So the electron configuration is just basically the standard notation used to describe the structure of an atom. Each electron will occupy an orbital. The order of the energy levels must be written by increasing energy. Each electron in each subshell will be shown as an exponent. In the short notation, you would just put brackets around the noble gas that comes before the element you're looking for on the periodic table. But the long notation, you just basically write out the whole thing, which is what I'm going to be doing, just because the different elements really aren't that far on the periodic table in my molecule. So the orbital angular momentum, there's a quantum number L, and that indicates the electron, that indicates the subshell of the electron. You can tell the shape of an atomic orbital from this quantum number. So basically, the subshells of S is L equals 0. So it's basically L minus 1. The subshell of 1 is P. The D subshell is L equals 2, and the F subshell is L equals 3. We're not gonna really get past that. So the magnum quantum number represents the orbitals of a given subshell. That really is not going to be too much into consideration. It can be negatives, it can be positives, while the L can only be positive. For example, a p subshell, L equals 1, can have 3 orbitals corresponding to m equals -1, 0, and +1. The spin magnum quantum number is just, it can only be +1/2 or -1/2. It just kind of shows like if it's spinning left or right. I don't know how to pronounce this, but the building up principle basically occupies the orbitals and just increasing energy. Okay, so let's start. I have like the periodic table. So we'll start with carbon. That's the first one. That's the first element. It's really not that far. So basically how we would count, this is the S's. S is only going to be S1 and S2. It just depends on 1S1 and 2S. So we'll start counting. So first of all, I'd go 1S1, 1S2, 2S1, 2S2. And then here we're now into the P. Now we're into the P orbitals. Those have 6, but we don't quite get to 6. We just go 2p1, 2p2, and that's the configuration for carbon. So we'd write 1s2, 2s2, 2p2. So these are the different shells. This is the last one. So there will only be 4 valence electron. This is really hard. Okay, and you need 8 to fill it. So okay, so then we'll go with hydrogen, H. Basically 1s1, that's it. So it has 1 shell, 1 electron. So only 1 valence. And it will need 2 to fill its outer shell. So then we'll go with Br. This only has a 2nd ring. Forgot to write that. And then Br. To count to bromine, that is right here. This will be a little farther down, and we're going to get into the d orbitals. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we get into the D's. So D is n-1, so it would be 3d10, 4p5, because we only get here. So the 2 valence, so it will be on the 4th orbital, and there will be 7 valence electrons, so we have 4 rings. Okay, so to draw the different elements, we'll start with the hardest one, bromine. So there will be 4 rings. Draw bromine while recording. So this is basically, there's 4 rings. 1, 2, 3, 4. And there is 7 valence electrons. The energy level increases as it moves farther away from the nucleus. So these are the highest level, energy level electrons. So carbon's easy. 2 rings. 1, 2. How many valence? 4 valence. So we have 1, 2, first ring's filled up, and then 1, 2, 3, 4. Once again, these are the highest energy level. So then we have H. That is 1 ring and 1 valence electron, only needing 2 to fill it up. Okay, so before we talk about electronegativity, I'm just going to figure out how many valence electrons we'll have in the actual structure of the entire molecule. So for carbon, we have 2 carbons and we have 4 valence electrons. So we'll do 4 times 2 plus hydrogen, which is 1, and we have 2 of those, 2, plus bromine, which we have 7, so 7 times 2, and that equals 24 valence electrons. I pulled up an electronegativity periodic table. Basically, it increases going right and decreases going down. So bromine will be our atom with the highest electronegativity, basically. So bromine has a level of 2.8. We're going to need these later, trust me. 2.8. We have H, which is, let's see, what is H? That is 2.1. And then we have C, which is also pretty high, 2.5. Okay. So now to draw the structure of this molecule, I'll write it up again. C2H2Br2. Okay, so we'll start with we'll draw out the electrons instead of using the lines at first. So first, carbon can make the most bonds, so we'll put that in the middle. And then we'll draw H. And then Br. We need another Br. Okay, and then we'll draw their electrons. So carbon will want to bond with Br. And then the other 7 valence. And that has a complete shell, so we're basically done with that. Same thing here. Alright, so hydrogen just needs 2, so draw that. Now carbon. We'll draw 4 valence. And then, so basically neither of the carbons are completed. So what we need is a double bond in the middle. So both carbons have their valence electron shells filled. So then we'll draw it with lines, because that's how you can really tell the actual structure and then figure out what 3D structure it is. So we'll do the same thing we did. Hopefully I'll have enough room. And then we use these lines to signify bonds, so this is a double bond. So there will be no lone pairs here because all the shells are filled. but BR is going to have some. 2, 3, 4. Just this is its bond. So there are 1, 2, 3, 4, 5, 6 lone pairs. Okay, and there's a couple of basic Renaissance structures, meaning that this can be drawn in different ways. Basically, the only difference is, I'll just draw it out. That'll be easier instead of trying to explain it. And then we can have a hydrogen here. And then we gotta draw the lone pairs to complete the show. And basically it could also be drawn these two switched. And then you have the 3. There are 3 Renaissance structures. I'll draw the other one just to, doesn't take that long. No, we already drew that one. So this side would be H and this side would be BR. That's the only difference. So there's 3 different ways you can draw this. And there we go. We have the 3 ways you can draw. And now we'll talk about if the bonds are polar or non-polar. So first, we will start with, so basically I'll explain to you. So between 0 and 0.4, that will be non-polar. 0.5 to 1.7 level of an electronegativity, it will be polar. And 1.7 and up, it will be ionic, but we don't have any ionic bonds in this, just to tell you. Okay, so the bond between carbon and hydrogen, C to H. So we have 2.5, which is the level of the carbon. I don't know why I did that. Minus 2.1. And that equals 2 or 0.4. Then we have the C to BR. So we have 2.5 minus, I believe it was 2.8. Let me look. Yeah, 2.8. And that is equal to 0.3. And then we have the C to C, and that's just going to be 0. So 0.4, 0.3, and 0. All 3 of those are nonpolar bonds. They don't go above 0.4. So this is not a polar molecule, not very polar. So the 3D shape of this, because of its 6 lone pairs and it has 6 bonds, we will draw the structure to look, it is a square planar. And I'll draw it out for you really fast, what this would look like 3D wise. So this is, here we go. This is what it would look like, basically, having a different. There's not going to be really anything pulling because all of these are very non-polar, pretty much. So we have, this is basically the 3D shape of it, how it's going to be moving. And I think that's it. There's a